Hello students, in the class we discussed about different types of delays in the internet. So we know that the first delay is the processing delay, where our packets is checked for errors, address. So it is in the count of nanoseconds. And the second one was the queuing delay. So all your routers in the network has a buffer. So your packets are waiting in the buffer, which causes something called a queuing delay. And the third one we saw is the transmission delay. So the time taken for the packet to leave that particular device. So the transmission delay depends on the length of the packet divided by the data rate. And the fourth one we saw is the propagation delay. And the propagation delay is the time taken for a packet to move from start of a link to the end of the link. So the propagation delay depends on the distance d divided by the speed s. So these are the four delays, and the total delay in a network is nothing but the processing delay plus queuing delay plus transmission delay plus propagation delay. So in the coming slides we will see some numerical problems related to this delay. So let us take for this scenario. So here it is a analogy which is very similar to that of what is happening in the networks. Here let's say we have a toll booth, and in every booth your packet, maybe when your car arrives at the booth, the car is processed. Okay, the FASTag of the car is processed, and then the car leaves the booth, and the distance between two booths is 100 kilometers. So say for this example there are three booths which is very similar to that of three routers. And it is given that assume that the propagation speed is 100 km per hour. So the total number of cars is 10, and the speed is 100 km per hour, and the distance is 100 km. And let's find out what else is given here. Toll booth takes 12 seconds to service the car. So it is very clear that the time taken to process a car, okay, so the processing delay is very straight away given here as 12 seconds. Okay, it is for a per car. Okay, per car the processing delay is 12 seconds. So if you take what is the question asked is, suppose a caravan travels 100 kilometer beginning in front of one toll booth. So you imagine it starts here, okay, and passing through the second. So it crosses this link, all right. It passes through the second one and just finishes after the third. So what is the time taken? What is the end-to-end delay for a car to start here and to end here? All right, that was the question asked. So the first delay is the processing delay. So it is asked that what was the time taken for all the 10 cars. Okay, so what is the end-to-end delay for all the 10 cars to move from the starting point here to the end point. So the processing delay for a car is given as 12 seconds. So what will be the processing delay for 10 cars? Okay. It is 12 into 10, which is equal to 120 seconds, right? And now every toll booth is processing this particular message. So the total processing delay so because there are three toll booths, I just say 3 into 120 seconds. Right, and it is nothing but 360 seconds. So when I try to convert that into a minutes, I just get 6 minutes. I'll divide this by 60, I'll get 6 minutes. So this is a processing delay. Now the second delay, that is queuing delay. No data is explicitly given related to queuing delay, so let us assume that it is negligible. Similarly, related to the transmission delay, the length of the packet, the data rate is also not given. So let us just ignore it. The next So next we will calculate the propagation delay. So propagation delay is nothing but distance divided by the speed. So here the distance is given by 100 and the speed is given by 100 kilometers. So we say it is 1. So the propagation delay is 1 hour, and there are two links available. So here is the starting point of a packet and here is the ending point of a packet. So it has to cross two links. So the propagation delay for one link is 1 hour. So 2 into 1 is 2 hours. So already we have calculated that the processing delay is 6 minutes. So when we add it together, the total delay is nothing but 2 hours and 6 minutes. Let us discuss the next problem. Here, how long does it take for a packet of length 1000 bytes to propagate over a link of distance 2500 kilometer? The propagation speed is given, data transmission rate is given. So more generally, how long does it take for a packet to propagate is the question, that is the delay is asked. So let us first take and write the given values. So the given value is L is 1000 bytes. So here it is given in terms of bytes. Right. And next the distance is given as 2500 kilometers, and then the speed is 2.5 into 10 to the power of 8 meter per second, and then the transmission rate given is 2 megabits per second. So first let us consider the transmission delay. So the transmission delay is L, length by the rate. So L is given as 1000 bytes. So in order to convert that into bits, let me just multiply it with 8. And then the data rate is given as 2 mega. So I just put 2 into 10 to the power of 6. So when you just calculate everything, so 4 into 10 to the power of 3. So 10 to the power of 6, when it goes up, it is 10 to the power of minus 6. So it becomes 4 into 10 to the power of 3, which is nothing but, 10 to the power of minus 3, which is nothing but 4 milliseconds. So the transmission delay is done. And next coming on to the propagation delay, where the propagation delay is nothing but distance by speed. So distance here given is 2500 kilometers. So I wish to convert the kilometers into meter. So when I convert the kilometer into meter, I have to multiply it with 10 to the power of 3. And then the speed is 2.5 into 10 to the power of 8. So which is written as 25 into 10 to the power of 5 divided by 2.5 into 10 to the power of 8. So when I just cancel these two, it becomes 10. So now this has become 10 to the power of this has become 10 into 10 to the power of 5 into 10 to the power of minus 8. So it has become 10 into 10 to the power of minus 3, which is nothing but 10 milliseconds. So let's take the total delay. So the total delay is, already we have calculated the transmission delay is 4 milliseconds. So 4 milliseconds plus 10 milliseconds, which is nothing but 14 milliseconds. So this is how we calculate the total delay for this question. So let us take the next question. Two devices connected via a link. So there are two devices the total distance between both the links is 4 kilometers. So distance given is 4 kilometers, and the propagation speed, okay, the speed given is 250 meter per microseconds, and the packet size is also given 500 bytes. So first let us take and write what are the given values. Now we calculate the propagation delay. So only the propagation delay is asked. So we will take only the relevant values, distance by speed. So distance is 4 kilometer. So kilometer, I wish to convert that into a meter. So I just do 1000 to it in order to convert a kilometer into meter, and then a 250. So when you do a total cancellation and calculation, I just get 16 microseconds. So it is enough that you calculate only the propagation delay as given in the question.